Hello, today we speak about how to connect programming and control from PLC our integrated drive miniature tubular linear motors NLi080Q. First of all, we have to install the NiLAB Starter PC Software interface downloading from our website NiLAB.at. After installation, we have to click 2 times on the icon to start. And then we have the interface ready. This interface is divided in 3 sections. The top line is related to the connection, the download and upload of the configuration to and from the motor, and to save and load from file a pre-saved configuration. On the left side we have the drive status, and here you can see the digital input and output state, the motor access status, and all the buttons to start, to switch on, and to fault reset. In the central window we have a motion controller configuration, the controller inside the drive with all the gain on the loop, the oscilloscope to acquire internal information like speed, current, and so on, and the motor parameter window where the numbers related to the integrated linear motor are stored. So we start connecting the motor to the PC, selecting the right COM port, in our case COM4. So connect to motor, and the internal configuration is loaded on an interface. In this window we have the current information about the data in interchange between the PC and the internal drive of the motor. So first of all, we have to configure a demonstration, for example, in automatic loop. So we start with a table like this, just 2 position, I/O control is disabled, and then 2 positions are stored, for example 5 mm and 60 mm with 100 milliseconds acceleration and deceleration, 300 millisecond waiting time, and the second step 300 millisecond acceleration, 300 millisecond deceleration, and 600 milliseconds waiting time. So download first this configuration to the motor, clicking on download configuration 2. Then the new configuration is stored inside. Okay. Then the first step is making automatic homing from PC interface. So clicking on automatic homing, the motor is making the 0 point and then start to execute the sequence on the table. Okay. In order to change the motion cycles, just to change the number on the table and then store using download configuration to the motor, and the new configuration is executed. You can see on the left status area the actual position and the actual speed. For example, if I disable the drive and move the shaft by hand, the actual position is calculating in real time, and you can use also these to take the number for the table. So position 1, 94, and position 2, 27. Then let's accelerate the motor, making half for all number in the tables, and then download, then enable, and start the motion. And then we have the motion between 2 points stored on the table. Then, in order to increase the speed, we can also decrease the waiting time on the 2 rows of this table, then download, and the motor is moving faster. On the right side of the motion table, you have information about the motion profile. Okay. Right now, with this number, we have a 48 motion per minute, a cycle time of 1.26 seconds, and a Newton motion of 44%. Okay. Let's move to control the motor using a simulated PLC. Okay. This box simulates the PLC with 2 outputs, digital output 0 and digital output 1, that is connected to digital input 0 and digital input 1. So these 2 switches simulate the command from PLC. So let's control by this simulator. So disable the motor, change to I/O control, and set the trigger mode to digital input rising. Then download. If I click now on enable, nothing happens because the control is passed to the box, to the PLC. So with digital input 0, we enable the motor, and with digital input 1, we trigger the table. Done. 1, 2, 3. At every switch on of digital input 1, the motion sequence is executed. At every rising edge of input 1. Okay? The same is possible from every single line of this table. Just selecting the second one and download, and then from every rising edge we have the single row of the table executed. Okay? This command normally comes from PLC, 24 volts output, and the motor is used this to trigger and also to send from the motor to the PLC information about the enable and fault. So let's go again on the PC control. So switch off the digital input 1, switch off the digital input 0, then disable the I/O control and move to auto and auto on the table and download the configuration. Now again our control is on the PLC and we can start the trial motion using these 2 buttons, start motion, and then we have again in automatic sequences. Let's show you the use of the scope. Can be interesting to see the internal signal using the oscilloscope function. So go to scope, select for example the speed feedback, the set speed, and the encoder sine cosine signal. So selecting, downloading the configuration, selecting the trigger source and the trigger level, and the start acquisition. We have to wait a little bit, and then we have the signal ready of our oscilloscope. So let's change the scale on the scope, and you can see here in yellow the motion profile generated internally, and in purple the motor feedback. You can show every signal you want, selecting on this drop-down menu, okay? But you have for every change to download a new configuration to the motor before start acquisition. Okay, for today is enough. Let's try again in the next video. Bye bye.